Hello everybody, I'm going to solve all the numericals of assignment 3 one by one. So let us begin with question number 1. In question number 1, there are two persons, Ram of 50 kg and Sam of 80 kg. They are standing 5 meter away from each other, means this is distance. So when they do so, what is the force of gravitation between them? So based on this question, let us draw one figure. So this is Ram, all right, of 50 kg, and there is Sam of 80 kg, and they are standing 5 meter distance from each other. So in this case, what is the force of gravitation between them? Now based on this question, let us write solution and given. So solution and given, mass of Ram, let's give symbol m1 equal to 50 kg. Similarly, mass of Sam, m2 equals to given 80 kg. All right, this is mass of Sam, and distance between them is small d equals to given 5 meters. Now we have written all the given. Now let us write question. The question is force of gravitation. Force of gravitation, symbol is capital F, equals to what? Now we have formula. The formula to calculate force of gravitation is F equals to capital G m1 m2 by d square. Now let us put the value of capital G. Capital G is universal gravitational constant and its value is always fixed, that is 6.67 into 10 to the power minus 11, and m1 is 50 kg, so that's why in place of m1 we are writing 50. m2 is 80 kg, so in place of m2 we are writing 80, and distance is given 5, so that's in place of d we are writing 5 square. So let us calculate using calculator. Now I'm using scientific calculator to find the value. So I'm going to multiply the upper one, so 6.67 times 10 to the power minus 11 and multiply 50 and 80, means it comes 50 times 80. So when you do so, then how much you get is it will come 2.66. After decimal you can write 2 digit into 10 to the power minus 7 divided by 5 square, means it is 25. So finally F equals to, if we divide by 25, then answer comes is 1.06 into 10 to the power minus 8 Newton. So this is our final answer. That means when Ram and Sam, they are standing 5 meters apart, then the force of gravitation between them is 1.06 into 10 to the power minus 8 Newton, which is very small value. So that is why Ram and Sam, they cannot feel the force of gravitation between them, because it is very much a small amount. So let us conclude it. So you can write, hence required force of gravitation is 1.06 into 10 to the power minus 8 Newton. Now let us go to question number 2. Question number 2. So read the question. There are two bodies. There's one body, mass of one body is 80 kg, and there's another body of 1200 kg, and they are kept 10 meter apart. That means the distance between them is 10 meter. In that condition, what is the force of gravitation between them? So based on this question, let us draw one rough diagram. So this is question number 2. So there are two bodies. This is one body and this is another body. Let us suppose mass of this body is 80 kg according to question, and mass of another body is 1200 kg, and the distance between them is 10 meter. So in this context, what is the force of gravitation between them? Now let us write solution and given. Solution and given. So write mass of one body, m1 equals to 80 kg, and mass of other body, m2 equals to 1200 kg, and distance between them is 10 meter, and asked here is force of gravitation. Force of gravitation F equals to what? Now we have F equals to capital G m1 m2 by d square, and now keeping the value of all those give quantities, capital G value is always fixed, 6.67 into 10 to the power minus 11. m1 is given 80, you can see here 80, and m2 is given 1200 kg, and distance is given 10, so that's why d square means 10 is square. So let us do the calculation. So I'm going to do calculation, upper one, let's check. So 6.67 into 10 to the power minus 11 into 80 into 1200. So it comes 0, after that 5 0, 1 2 3 4 5 6 4 by 100. 10 square means 100. So finally answer is divide by 100. So 100 means it will come answer is 6.4 into 10 to the power minus 8 Newton. So conclusion is, hence required force of gravitation is 6.4 into 10 to the power minus 8 Newton. So the force of gravitation between these two bodies is 6.8 into 10 to the power minus 8 Newton. Now let us go with question number 3. Question number 3. There are two spheres. The one sphere is having mass 40 kg, and there is another sphere having mass 15 kg, and the attraction between them is force attraction is 9.8 into 10 to the power minus 7 Newton. So if the condition is so, then what is the value of universal gravitational constant? So capital G is asked here, and the distance between them is 20 centimeter apart. So question number 3, based on this, let us draw a diagram. There are two spheres. All right, there are two spheres, and this is the center of the sphere. The force of gravitation between them is, according to question given, is 9.8 into 10 to the power minus 7 Newton. Okay, and the mass of first sphere is 40 kg. Mass of another sphere is 15 kg. All right, and the distance between them is 20 centimeter apart. So in this condition, you are asked to calculate universal gravitational constant. Though we know value of capital G, but in this question it is asked to calculate value of capital G. So based on this, let us write given solution and given mass of first sphere M1 is given how much? 40 kg. So let us write 40 kg. Mass of second sphere M2 is given, that is 15 kg, and the force of gravitation is given between them is force of gravitation is given here 9.8 into 10 to the power minus 7 Newton, and finally distance is given here 20 centimeter. So we have to do numerical in SI units, so that's why we are supposed to convert the centimeter into meter. For that we need to divide by 100 because 1 meter has got 100 centimeters. So after division it has turned into meter, so you'll get answer is 0.2 meter. So we have written all the given. Now question is capital G equals to what? So that's why you are asked to calculate universal gravitational constant value. Capital G equals to what? Now we are going to use same formula. We are going to use same formula, that is F equals to capital G M1 M2 by D square. Now let us put all the values. So F value is given here 9.8 into 10 to the power minus 7. So I'm going to put that value 9.8 into 10 to the power minus 7 equals to capital G is asked here. So let's give as it is. M1 is given 40 kg, so 40. M2 is given 15 kg, so I'm writing 15 here, by distance is given 0.2 square. So let us simplify it. 9.8 into 10 to the power minus 7 equals to G. Here 40 and 15 means it comes 600 by 0.2 whole square means it will come 0.04. Now when you bring 0.04 on left hand side, it will multiply, so it will become 9.8 into 10 to the power minus 7 into 0.04 equals to, on the right hand side the left is G times 600. Now since we are going to calculate G, so that's why let's bring this on right hand side, left hand side. So let's change the side. So G is to, G times 600 equals to 9.8 into 10 to the power minus 7 into 0.04. We are just changing sides. Or G equals to 9.8 into 10 to the power minus 7 into 0.04. If we take 600 other side, it will divide, so 600. Now let us do the calculation using scientific calculator. So now I'm multiplying using calculator. 9.8 times 10 to the power minus 7, 10 to the power minus 7 into 0.04, 0.04. It comes 3. It comes 3.92 into 10 to the power minus 8 by 600. Now when you divide by 600, the answer will come is 6.53 into 10 to the power minus 11, so which is almost equivalent to the real value of G, and the unit of capital G is Newton square meter per square kg. So this is our answer. So let us conclude. hence required universal gravitational constant value is 6.53 into 10 to the power minus 11 Newton square meter per square kg. Now we are going to do question number 4. Let us check the question. The force of gravitation between two bodies, there are two bodies, is 6.67 into 10 to the power minus 7 Newton, and mass of each of them is 100 kg. Means there are two bodies and mass of each of them is 100 kg. So in that condition, what is the distance between them? So let us draw one figure based on this question. Question number 4. So there are two bodies, alright, and mass of each of them is 100 kg according to question. And the force of gravitation between them is 6.67 into 10 to the power minus 7 Newton. So here it is asked the distance between them. What is the distance between them? So let us write solution and given. Solution and given. So right solution is mass of first body m1 equal to 100 kg, mass of second body m2 equal to also 100 kg, and the force of gravitation between them is capital F equal to 6.67 into 10 to the power minus 11 Newton. Now distance is asked. Distance t equals to what? So we'll be using same formula. We have F equals to capital G m1 m2 by d square. So now keep those values. F value of F is given here, 6.67 into 10 to the power minus 7 Newton. So let us write that value, 6.67 into 10 to the power minus 7 equals to capital G value you know already, 6.67 into 10 to the power minus 11. M1 is given 100, so let us write 100. M2 is given 100 again, so 100. And now distance is asked to us, that's why let us write as it is. Now take d on left hand side, so it will multiply. So 6.67 into 10 to the power minus 7 into d square equals to 6.67 into 10 to the power minus 11. If you multiply this 100 and 100, it becomes 10 to the power 4. Now d square equals to, if we take on right hand side, it will divide, so that's 6.67 into 10 to the power minus 11 and my 4. This, if you just do the simplification, it will become 10 to the power minus 7, and if it go on right hand side, it will also divide 6.67 into 10 to the power minus 7, or d square equal to, the quantities are similar, that's why they cancel, so that's the answer will come 1. They cancel, so, or d equals to root 1. That means finally you got d equal to 1. Since it is SI units we are using in all quantities, so that's the distance means SI unit of distance is meter. So this is our answer. That means the distance between them is 1 meter. So we can write hence required distance is 1 meter. Now finally we are going to do question number 5. Question number 5, let us read the question number 5. Calculate force of attraction between two bodies. Means this is our question. This is our question. With the mass is 100 kg, means here also mass of both of the body is 100 kg. And they are 1 meter apart, means distance between them is 1 meter. Okay, that is one question. And there's another question: will the force of attraction be different if the same bodies are taken on the moon? So if we take on the moon, what will happen to the force of attraction between them, keeping the same value? Means mass also same and distance also same. So we'll be solving both of the question one by one. So question number 5. So let us draw one figure based on this question. There are two bodies. All right, there are two bodies, and mass of them is 100 kg, and distance is 1 meter apart. 1 meter apart, and the force is asked to calculate here. What else given? Okay, we have written all given. That means what is asked to us is force of attraction is asked to us. So let us write solution and given. Solution and given. So right here, mass of first body m1 equal to 100 kg. Mass of second body m2 equal to given 100 kg, and distance between them is 1 meter. So what is asked to us? Force of attraction between them, means it is force of gravitation. Force of attraction, capital F equals to what? So we are going to use same formula. We have F equals to capital G m1 m2 by d square equals to capital G, you all know the value, 6.67 into 10 to the power minus 11. M1 is given 100 kg here, so let us write 100, and M2 also given 100 kg, so we're writing again 100, and distance is given 1 meter, so 1 is square. So it is going to be more easy. So let us multiply 6.67 into 10 to the power minus 11. Here 100 means it is 10 to the square, and 100 means again 10 to the power square. 1 square means 1. So finally, if you simplify it, then your answer will come 6.67 into 10 to the power. Here power will add and subtract, so you will get final answer is minus 7 Newton. So it is just opposite of question number 3. See here, distance is given 1 meter. Here also given distance is 1 meter. So 4 and 5, they are correlated. So let us conclude it. Hence, force of attraction between them is 6.67 into 10 to the power minus 7 Newton. Okay, everybody, with this we finish assignment number 3. I solve all questions here given. So check this video again and again if you have any confusion. Thank you so much.